Yeah, this is my second EV conversion. It's actually the Matiz. I specifically chose it for its size. I wanted something very, small in size, so I could save weight and have enough battery power to move it. So I chose this car for its size. Though it didn't have a lot of space to contain the battery capacity I wanted, but it was enough to get me on the road for a long period of time. Yeah. So here is the bonnet. Yeah. Uh, the AC works. I chose an external motor to run the AC compressor. The external motor I used was a washing machine motor. This smart drive motor, flat BLDC motor, and I designed the controller. That's the controller for it. For the motor runs the compressor and the power steering pump with a pulley and belt. That's the arrangement. So I run my compressor for the AC and also the power steering pump for the steering to ease the stress in, using the steering. So right here in this box, I'm not sure if I can handle the stress of opening it right now, but I'll just tell you what's here. This is the inverter. I used a three-phase AC induction motor driver. I actually converted a contemporary VFD controller. I had to manipulate it, do some conversions and some circuit arrangement and rearrangements to be able to come up with a 100 amps 216 volts three-phase AC power. I used IGBTs, single models IGBTs, three of them, to run the output of the VFD. And here you have, I had to incorporate some kind of output power supply that could feed your house. It runs your ACs, your fridges, and whatever you have in your home. You can actually use this car to run these things. I'll come back to this later. There's a whole lot in this box. I'll come back to it later. So that's the auxiliary battery that runs the accessories, the radio, the lights and stuff. Just the 12 volts, normal 12 volts auxiliary battery. And here is a fuse box, for that. Yeah, coming this way up inside the car. Inside the car, you can actually see that the car is charging, and I have an indicator, a kind of LCD infotainment to tell you what's going on, the battery capacity, how it's charging, the battery charging bar, and everything, all the information you need regarding the battery and every other stuff, the temperature, the speed and stuff. This is for the battery, right? It takes care of the battery when it's charging and when it's discharging. The current and the wattage and everything is here. Now these are the ones, like if I put the vehicle on, you would see that the rest of the displays are on right now. This one tells you about the voltage on the auxiliary battery. That's 12.8 volts. It maintains that voltage because I have a DC to DC converter that does the job of charging the battery. That takes the place of the alternator in the regular car. And this one takes care of the temperature of the motor and of the controller. Yeah, so when the temperature gets above the limit, the set limit, it cuts off a certain circuit and triggers a fan to cool the system. I actually used an air cool system because I couldn't handle the stress of running a liquid cool system and this stuff. So everything is air cooled, the motor is air cooled, the controller is air cooled, so there's a temperature gauge for it. Now this this one wasn't connected yet because I intended using a solar system on this car, a solar roof, but that hasn't been effected yet, so it's still going to be there, till when I'm ready for that. So this one does the job of the digital tachometer. It tells me the speed, how fast I'm traveling and stuff. So I'm going to do a video on that. And this one, when I'm driving, I'm going to show you how it counts the speed of the car. That's a vehicle speed sensor. Now this one tells you the condition of the gear. Yeah, it's on drive right now. That's why it's showing D. If I select this button here, it tells you neutral. If I put it down, it gives you reverse. So I use this in place of the contemporary shifter, the gear shift right here. Though this one is still in use, it lets me select whatever speed I desire, whatever gear I desire. If I desire to go with third gear, second gear, fourth gear, fifth gear, whatever gear I want to choose, depending on the how good I want to manage my battery, I could select the gear. So I also have a reverse camera display. If I put reverse, it goes reverse. It shows me what I have back there. So it's another infotainment to take care of the reverse situation stuff. And next is the regular vehicle dashboard. The fuel stuff doesn't work no more because the vehicle doesn't have a fuel in it. It's the battery that's doing the magic right now. The speedometer, the manual speedometer, that's the odometer. It still works. The trip meter still works, and the engine rev doesn't work no more because I couldn't connect that. I couldn't take care of that. Yeah. So every other thing in the car, the hazard light, every other thing works as normal. Nothing has been changed. Everything is still stock. Yeah, you can see it's showing check engine because the engine is no longer there. So yeah, that's pretty much it. I'll show you my battery. Okay, that's the switch for the AC. The AC, yeah, if I press this button, the AC will come on. I will show you that in a bit. Back here I have the battery packs, the floor packs. It's actually a false floor kind of pack, so you wouldn't really know that there's a battery here. So I put a 27 volts lithium ion batteries. That's 18650s that I recycled. I actually reclaimed a lot of batteries, and that's exactly what I used. Yeah, with the BMSs inside, so you can see the inside. I had to put the BMSs and some ST60 connectors to help me check the batteries if I want to access individual packs. It's actually 7S I think 7S 180p. I can't remember the configuration, but I have that on paper. So that's it, a false floor, second battery pack. Yeah. And again, the main disconnect switch is here, just in case you run into an emergency, you want to put the car off. Yeah, there's an emergency switch right here. It's actually a 250 amps high-powered breaker that breaks the entire unit. It breaks the connection from the batteries to the controller. So that puts the car in a safe mode. Now, down under the seat, I have the main battery pack. Let me show you that. Yeah, you can see the battery packs under the seats. That's the way I configured them. These packs takes the place of the regular fuel position where the fuel tank used to be. So I have a majority of the pack right here. It's all locked up. I can't handle opening them right now, but I can assure you what you have here: 18650 reclaimed batteries. They're about 8 packs of 4S each by I think 150p. Yeah, I think that's what I have. I'll show the paperwork on that. So that's it. The second battery pack. That's the main pack. Now let's go over to the boots. That's what we call it here. So down here in the boot, we have the overall BMS. They are locally made BMS. They are handmade. Circuitries are handmade. You can see the wiring is a little untidy, but that's just it for now. I've been using this car for more than 1 year, so I decided to make a video of it for avoidance of doubt. People who doubt that it's not possible for an African guy to convert a contemporary ICE car to full-time electric. So this is a part of my equipment, the battery charger, the battery tester. Sorry. So under here, where the tire, the spare tire used to be, the spare tire is still maintaining its position. But under the spare tire, I have another pack to complete the entire pack to a 216 volts pack. I can't leave the tire right now, but I can show you right under the car. You can see the pack. The battery box right under the car. So it's a drop-down pack that's just under the the spare tire well, right? So that's it. That's under the car. You can see, you know, I don't know if you can see it very well, but that's the much I can, handle right now. That's it. So at the moment, the vehicle is charging. It's plugged in. That's the plug-in wire. Yeah, and I actually set up an independent power supply for this purpose, because I know electric cars draws a lot of power when they're charging. So I had to dedicate this power unit, this power system, solar system for it. That's the inverter providing power from the batteries. These are the batteries I stocked up here. I'm not sure if you can see this well. Yeah, these are the batteries I put up. Don't worry about it. Got the batteries and the inverter. Up there is actually a 5 kilowatts inverter that handles the charging. And up here you can see the solar panels all mounted on top. Yeah, I have like 6 panels there. You can see 5 here, and 1 is on the roof. And there are more panels here, and more panels this way. So this thing actually takes a lot of power, so I decided to put up enough solar panels to handle that. So that's basically it. I'm gonna do a drive test right now to show you how it works. I'm gonna plug it from charging and roll it out. Let's see how it works. I can pause it. Okay, no worry. Okay, we're in the car right now. We want to do some kind of a drive test. Now, to start the car, you just need to turn your key on this way in this position. That's all. That's it. That's pretty much it. And you see this display would ask you to wait that the electric car is starting up. Okay. Well. Okay. Yeah, it tells you that the car is ready, right? To move. The gauges are on. Everything is set. We're set. We're good to go. We're set to take off. Right now, I select reverse because I'm going to drive out. You see the display, the reverse screen telling you it's ready. So we drive. Close the door.
As the speed, wow, the car actually maintains its normal speed just like every other vehicle, just the way it came, just that this time it drives on batteries. It's waiting. He's actually on a drive test and he's on his way back. This is amazing. This is amazing. It's gonna drive right back in. Wow.
Now we're driving down the road, and you can see we're doing 20, 28, 29, 30 kilometers per hour on the road. Yeah, It has a lot of torque. When I say torque, the torque is tremendous. It has regenerative braking. It has a regen braking. It happens whenever I want to brake. If I lift my foot off the accelerator, the controller will sense that I need to, I'm off, and it sends excitation voltage or signals to the motor to turn it to a generator. So the regen braking works very well. Yeah, we're doing 40, 43 on the highway. Yeah, we're doing 48, 50 on the highway. Are you covering it?
Yeah.
I'm regenerating right now. My foot is off the stuff. You can capture here. Oh, God. That was a brief regen, a very hot regen. It pulled voltage from the motor back to the batteries via the controller. So that's it. So much torque. So much torque in this car, can I show you? So much power in this car. Yeah. That's it. I love electric cars. Electric cars are very, very powerful. Has so much torque. So much torque, I can tell you. I'm regretting that I'm leaving this car, honestly. This has been my daily driver for like a year or two right now. And leaving this car to move over to Canada is really hurting me. I'm not sure if the Canadian government will allow me to do a thing like this in Canada. But I'll just show them what I have. I'll show them my stuff. If they would allow me, I'll do more of this. This is locally made. I mean, I converted this locally with a piece and parcels of equipment in my workshop, in my garage. Yeah, there is no foreign equipment here. I didn't buy motor. I wound the motor myself. I did the winding. I just bought a contemporary 3-phase induction motor. It's actually a 4-pole 10 horsepower motor that I bought from the market. I unwound it, removed the industrial winding, the factory winding, then I put in my own winding with my calculations. I have these things on paper. So when I was done, I was able to achieve 15 kilowatts or 16 kilowatts worth of power. That is a continuous power. Then max power is around 30 kilowatts of power. That's what's pushing this motor, this vehicle. I am aware it's not close to the original capacity of this car. This car requires 47 kilowatts worth of engine power to drive it originally, but I was able to generate 32 kilowatts of power. But it was enough to move this car. Very fast acceleration. You can watch that. You can see that. Very smooth and powerful acceleration with regen braking. Yeah. It handles very well. It's a lovely car. So that's pretty much it. I'm not sure if I have any more thing to tell you. The AC is on right now. It's rocking. I'm not sure you can feel it from there, but I can assure you it's working. The AC is perfect. It cools very well. That's a setting. You can see how setting from 1, 2, 3 to 4. You can feel the noise, the air buzzing from the vents. So it's marvelous. Then right here, this is the controller. The controller dash display board, my input board for the VFD. So I can manipulate here to select parameters that I want to adjust the VFD. That's my controller, my motor controller. So this is actually a part of the VFD that I have in the hood. So I can put in parameters to help me adjust, make some adjustments in my controller, in my speed controller. Yeah. I think that's it. Heading back to the house right now after I prolonged the speed test. That's regen braking. Very brisk, powerful regeneration braking. Regen braking is very tough. It puts out like about think about 80 amps back to the battery. Yeah, I get about 80 amps back to the battery with the regen braking. It's awesome. Honestly, it's a shame I'm leaving this car behind. Honestly, I'm really not happy. Not happy. If it was possible, I would have loved to take this car along with me to Canada. But I'm sure that's not going to happen. I mean, they won't allow that. Yeah, that's about it. Going back to the house, you can pause. Maybe just speak this to you. So okay, let me show you again. Now that's the gear, the hand gear I told you about. I'm using gear 2 to make this video, but I can use gear 1 too. If I put on gear 1, I have a lot of torque, tremendous torque with gear 1, but I won't have so much